morning to everyone. Last video we can discussed about the engineering mechanics and applied mechanics. In this video we can going to see about the introduction of finite element analysis. A finite element method is a numerical method for solving problems of engineering and mathematical physics. So already we have discussed in the engineering mechanics and applied mechanics. In this engineering mechanics we can apply the physics laws to the mechanical problems. So that is called as an engineering problems. Then applied mechanics, we are converting an engineering problem into a mathematical model. That will be a mathematical physics. Either it will be in an engineering mechanics problem or it will be an applied mechanics problems. We can able to solve by using a finite element methods. In this method, a body or a structure in which the analysis to be carried out is subdivided into a smaller elements of finite dimensions called finite elements. Any body or structure we are going to analyze means we can carry it out into a small portion, subdividing a small portions. That is called as a discretion. Equal number of small portions. So initially first we want to do a discretion process, that is called as a whole body we can split it into an equal number of small portions. That is called as an discretion. Then the body is considered as an assemblage of these elements connected at the finite number of joints called nodes or node points. For initially the structure object into converted in small portions. Then the small portions will be assembled together. That is called as an assemblage. Once if we assemblage, the structure will be converted into a finite element model. Initially it will be a structural model. Now it will be in a finite element model. For the small elements or portions connecting together, that connecting point is called as an nodes or node points. These nodes or node points are influenced to give any inputs to the structure or taken from output from the structures. That's we need a nodes. Next, the properties of each type of finite element is obtained and assembled together and solved as a whole and get the solution. We are applying the properties for material properties, geometrical properties, everything we want to apply. So that's why we are studying the solid mechanics. Geometry and then materials plays the major role. So properties for geometry or physical properties, anything we can apply for in finite elements. We are applying for small that elements and obtained finally assembling the every element equations together. Now we get the solution for a global components. That is called as a finite element. In other words, we are mentioning as a finite element as instead of solving the problem for a entire body in a one operation, we formulate the equations for each finite element and combine them to obtain the solution of whole body. So initially we are finding the solution for whole object in a one operation. Instead of this, we are moving to split it into a small number of elements and finding the solutions. Then we are combining or assembling the equations to find the final output of the objects. So this is the another term to derive the explain the finite element methods. So thank you for watching this video. We will see you in next video. Thank you.